Okay, hello everyone. This video is a continuation from continuation to the last video. In last video, we are talking about the calculation of the moment of inertia of composite area. Okay, and we finished the first part, calculate the moment of inertia of this complex shape with respect to the x-axis. Now we have to compute the other, and the remaining part is calculate the moment of inertia with respect to this y-axis. Okay, we just use the same strategy on the previous video. Okay, we just preserved all the geometry information from the last video. Okay, so now, okay, we use the same strategy. We cut this complicated area into these three different parts. Okay, and now we have to calculate the moment of inertia of each part. Okay, so we still from the middle part first. Okay, because middle part is much easier to calculate in this problem. Okay, maybe I just okay. So the middle part. Okay, the middle part is this area. Okay, and right now our rotational axis is y. Also, be careful. Okay, and you see this y-axis is pass through the centroid of of the middle part, right? This axis is passed through the centroid of the middle part. So you can use the formula use the formula to calculate the moment of inertia of the central part, moment of inertia of the middle part directly. Just use this formula. Okay, it's 1 over 12 and BH3 squared. But be careful, what is your B and what is your H? Be careful, because right now we are calculate with respect to y-axis. So if you calculate with respect to y-axis, B is here. Okay, so B right now is 100 millimeter, 100 millimeter, and your H high is 400. Be careful. It's different. Okay, look at this formula in detail. Okay, and tell the difference. It's not the same. It's not the same. Be careful. It's all about which rotation axis you are talking about. So we are dealing with y-axis. So right now our B is here and H is here. So B is 100 millimeter and H is 400 millimeter and the cubic 400 millimeter and cubic. Okay, so use your calculator. So don't forget to practice operating your calculator. Okay, because it's very important in this course. 400, and times 10 to the power minus 9 and divided by 12. So it's bh3 squared cubic. Is the same. The same. 43,333 times 10 to the power minus 4. Let me check. Is it the same? Let me check. Okay. Oh, let me check. Sorry, I just want to quick check my answer. Is this right? Mm, okay. Okay. Yeah, it's right. Okay, so this is the middle part. Okay, so the remaining part is the left and the right. Okay. And left and right, actually, they are symmetry. They are symmetry. So left and right have the same answer. So we only calculate the left or calculate the right part of the area. So okay, so let's still calculate the left. Okay, the left. Okay, so right now here and its central is here. So you have to be careful. Right now, the y-axis is not passing through the centroid of the left part. Okay. Yeah, I repeat it again. Right now, the y-axis is not passing through the centroid of the left part. Okay, so you cannot use the formula directly. So you need to use the parallel x theorem. Okay, okay. So, but we still use the formula to calculate the left part. Use this formula to calculate the moment of inertia of the left part rotating with respect to its rotational axis. Okay, so sorry, centroidal axis. Okay, and the BH3 BH cube. Okay, so right now here, okay, right now here we are the rotational axis is vertical, so it's vertical. So what is your B? What is your H? Be careful. So here is your B. Right now, your B is 400 times 10 to the power minus 3, and your H is 100 times 10 to the power minus 3 cubic. Okay, right now here is your B. Mm, Okay, right now here is your B. B is here. Okay, right now and here is your H. This is your H. Okay, because right now our rotational axis is a vertical one, is a vertical one. Okay, so your B is here, height is here. Yeah, vertical here, vertical axis. So your B is here, H is here, height is here. So be careful. So it's B H cubic divided by 12. But let's, for moment of inertia, for the left part rotating along his centroidal axis. Okay, but right now this part is not rotating along with its centroidal axis. So we need to use parallel x theorem. So we need to add the AD square. Okay, what is your A? A is the area of the left part. So it's 100 millimeter times the height, 400 millimeter, and we need to times the d square. Okay, what is the d? What is the d? D is the distance between the rotational axis with and your between this distance between your rotational axis and your centroid. Okay, so what is your d? Right now your d is here. This is your d. Okay, this is your d. Okay, so what is the d? Be careful. So here's a 50. So here's 12. I think here is 50 and here is 200. So it's 250. Right now your D is 250 millimeter. Okay, right now D is the distance between the rotational axis and your centroid of the left part. So it's 50, this is 50 millimeter, and here is 200 millimeter. Okay, so so your D is 250 millimeter and square. Okay, so let's calculate. Okay, what's the value of this? Okay, so 400 times 10 to the power minus 3 and times 100 times 100 times 100 and times 10 to the power minus 9 divided by 12. So the first part is 3.33333 times 10 to the power minus 5, and the other part, AD squared, is 100 times 400 times 10 to the power minus 6, 0.04. Okay, and then times 250 times 250, and times 10 to the power minus 6. Oh, really? Let me calculate again. Okay, sorry, I have to calculate again. 100, 6, oh, times 20, times 250. Minus 6. So it's 2.5 times 10 to the power minus 3. So add together, oh, it's very small. Okay, so it's 2.53333 times 10 to the power minus 3. And it's only the left part, so we have to times 2. Okay, so we have times 2. So 2 times left. So left plus right. It just times 2. So it's a 5.06666 to the power minus 3. Okay, so we add the three parts together. So what's the answer? Plus 5.333 plus 4. So it's 5. So the answer will be IY will be 5.599999 to the power minus 3. So it's very close to the answer from the textbook. It's 0.0056. Okay, and the unit is meter 4. Okay, meter power meter power 4. interpowerful. Okay, so this is about the remaining part of this problem. Yeah, so first of all, you need to know the formula of the formula for the moment of inertia for the rectangular area. Very uh, you need to familiar with this formula. Okay, and then plus with the parallel axial theorem. Okay, this is very important formula for the rectangular shape and the parallel axis theory, and you need to determine the distance between your rotational axis and the centroid of each part. Okay, okay, so I hope you need, yeah, you need some practice. Okay, okay, so here is the remaining part of this problem. Okay, so I just stop video here and see you in the next example by right here. The next video, yeah, I'll talk about, yeah, this is one of your problem from your textbook. Okay, so see you in next video. Bye bye.